Good morning, Geometry Honor students. So Mr. Chen again. So today I would like to talk about the lesson of writing the equation of a line with a parallel or the given perpendicular line with the given point. Okay, so let's take a look at that. So how can you write an equation of a line that is parallel or perpendicular to a given line and passes through a given point? So here's some of the practice problem, like the one that you can work out by yourself or you can work with your partner. Okay, so parallel lines, perpendicular, making the line here. So here's the first example. So find the coordinate of point P along that directed line segment AB so that the ratios of AP to PB is 3 to 2. So we don't know where that point is, point P, so somewhere along the line here. So the ratio is given as 3 to 2. So let's say that point P is going to be x comma y. So one thing that we notice, we can find the slope of the line segment AB first. So using that, the slope formula, so point A, it's considered x1, y1. Point B, it's x2, y2. So using the slope formula, we do have y2 minus y1 over x2 minus x1. So it's very important for you to recognize the slope formula. So 8 minus 2 all over the quantity of 6 minus 3. So what we found here, it's 6 over 3. Now, without reducing the number, so here's what we want to do next, the ratio. So as you can see that the total ratio here, 3 and 2, so combine them together, then that'll be 5. So the major ratio is considered 3 over 5. So using that, the major ratio, so we want to multiply by the rise. And also using the major ratio, we want to use that as the same fractions to multiply by the run. So 3/5 times the rise, which is 6. And then using the exact same major ratio multiplied by the run. The purpose of doing that, we want to find out the increment for the point, rise over run. So we can calculate that point P right there. So 3/5 times 6, which is 18 over 5. And then 3/5 times 3, then that'll be considered 9 over 5. So from point A, so we just count it, rise over run. So point P, then that'll be considered 3 plus the run, which is 9 over 5. And then for 2, so we just want to add it, 18 over 5. So again, the run is just the change of the x value. The rise is just the change of the y value. So just add those numbers correspondingly. So 3 plus 9 over 5, so what we found here, so 3 is 15 over 5 plus 9 over 5, then that'll be considered 24 over 5. And then 2 plus 18 over 5, so 2 is written as 10 over 5 plus 18 over 5, then that'll be 28 over 5. You can convert it to a mixed number, or you can just leave it as the improper fractions. Okay, so point P, so that would be the fractions. And then here's the other example, so you can try, so things that to work out, so the total ratio will be 5, so the major ratio is what, 4 over 5, 4 over 5, so get our slope here, rise over run, so 4 minus 3, divided by a minus 1, so you do have 1 over 7, so multiply by the rise, 4/5 by 1, multiply by the run, 4/5. So again, to get the increment, so 4/5, which is the what? This one would be the rise, and then 28 over 5, then that'd be the run. So just add it from point A. Okay, so 1 plus 4/5, and then 3 plus 28 over 5. So just finish that. And the other one is quite similar, same process as what we were doing. So here's another concept I would like to go through today. So Theorem 3.13, slope of parallel line. In the coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Okay, by conditional statement. So any two vertical lines are parallel, so normally they do have the exact same slope. And then Theorem 3.14, the slope of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is -1. So horizontal lines are perpendicular to the vertical line. So what this one is saying that if two lines are perpendicular to each other, so that means the slope, it's always considered negative reciprocals of each other. So if that's a negative reciprocal slope, so let's say that m1 it's negative 1/2, and then m2 got to be positive 2. So negative reciprocal. So once you multiply it, so the product it's always negative 1. Okay. So determine which lines are parallel and which lines are perpendicular. So basically you just need to find out the slope here. So for line A, so the slope of line A, so again using the slope formula, y2 minus y1, so 3 minus 2 over 0 minus negative 3. Again, this one you can always label it x1, y1, x2, y2. So 3 minus 2 all over the quantity, 0 minus negative 3. So what we found here is 1/3. And then the slope of line B. Okay, so basically using that the formula. So x2 minus x1 for the denominator. So 2 minus 0. And then the top, y2 minus y1, so 0 minus negative 1. So what we found here is positive 1/2. And then for the slope of line C, so slope of line C here, so y2 minus y1, once again, using that the slope formula. So negative 4 minus negative 5 divided by x2 minus x1, so 1 minus negative 1. So this one will be considered 1/2. So as you can see that slope of line B, slope of line C, those are the exact same slope. So that means B and C, they must be parallel. So line B is parallel to line C. Perpendicular line, we don't see any perpendicular line here, but let's get that the transversal. So don't forget about that's the slope of line D. Okay, so this one we haven't found the slope yet. So this one we do have the point, okay, so which is negative 3 comma 2, negative 2 comma 0, those are collinear. So subtract, so 0 minus 2, and then x2, negative 2 minus x1, so negative 2 minus negative 3. So what we found here is negative 2 on the top denominator, then that would be considered 1, so it's negative 2. So compare and contrast the slope here, negative 2, 1/2, 1/2. So that means the transversal, line D, is perpendicular to line B and line C. So line D is perpendicular to line B, and line D is perpendicular to line C. Okay? So determine which of the lines are parallel and which of the lines are perpendicular. So this one is a simple example that you can try, just like the previous one. So here's the one. Write an equation of a line passing through the point negative 1, comma 1, and that is parallel to the given line, y equals 2x minus 3. So anytime they see the word problem like this, you always want to highlight the key number, the key phrase, the key word. So the number that we have, the given point, x1, y1, the equation. And the key word is parallel. If two lines are parallel, so that means the slope got to be exactly the same. So using the slope intercept form, things that you did in algebra 1, so the slope for this line here is 2. So that means the line, the slope of the other line, the parallel line, it's also the same slope. So we're going to be using 2. And the point that we have already, which is negative 1, comma 1. So going back to what we have from algebra 1, in order to write the equation of a line without the y-intercept, so the way to do it is by using the point slope form. So the point slope form is quite similar to the slope formula. It's y minus y1, so that equals m times x minus x1. And for those you might be wondering, how do I get that? The slope formula is always y2 minus y1 over x2 minus x1. So for the denominator, the one underneath that m, there's nothing given, so that means always 1. And what happens if just think about that if this one's cross multiplication? So it's like m times x2 minus x1, so that equals y2 minus y1. So it just reverse the order, so y2 minus y1 equals m times x2 minus x1. So it's quite similar to the point slope form. So x1, y1, so this one is just the initial point. x2, y2, they're just considered the random point. So that's why this one can be written as y minus y1 equals the slope times x minus x1. Again, initial position, x1, y1, the point, it must be written with that x1, y1. But any random point, x2, y2, x3, y3, you can just put in general x and y. So by using the points low form, plug in the number. So what we got here, so it's 2 times the quantity x minus x1, which is negative 1. Put in the parentheses, and then y minus y1, so y minus 1. Distribute, simplify, so we do have 2x plus 2. And then f1 on both sides, so y equals 2x plus 3. So this one will be the parallel line, which is parallel to the given equation here. Y equals 2x minus 3. Again, same slope. But this one, the y-intercept, it's down negative 3. The other one is up positive 3. Okay, so now what about if we need to write the equation of a line that passed through the point, and this time the relationship is that it's perpendicular to the given equation, to the given line. So first thing that I want to do, so try to get the slope of this given line here. Subtract 2x both sides. So we got y equals negative 2x plus 2. So as you can see that the slope here is negative 2. So keyword perpendicular. We do have a given point, x1, y1. So again, anytime that two lines are perpendicular, so that means the slope got to be negative reciprocal. So if m1 is negative 2, so that means m2 must be positive 1/2. With the given point, 2, 3. And again, using the point slope form, so basically we can generate the equation of a line. So y minus y1, so y minus 3, so times the slope, 1/2, times the quantity, x minus 2. Again, distribute, so 1/2 x minus 1, f3 both sides, so y, so that equals 1/2 x plus 2. So this would be the equation of the perpendicular line, and which that line is perpendicular to 2x plus y equals 2. Okay, so write an equation of a line passed through the point 1, 5, parallel, perpendicular, so quite similar to what we were doing. So how do you know that the line x equals 4, y equals 2, are they perpendicular? Yes, they are. The reason why that is for the special cases, so if that's y equals a number, so that means the slope is always 0. X equals a number, so that means the slope is undefined. Well, because that one of the line is considered vertical, if that's x equals a number, it's a vertical line. Y equals a number, it's a horizontal line. So once you sketch the graph, you'll see that. So y equals 2, right up here, supposed to be solid. And then the other one, x equals 4, 1, 2, 3, 4, vertical, it's also solid. So as you can see that, so this one is like 0 over 1. Undefined, that means consider the reciprocal, 1 over 0. There's no negative positive for this one, because 0 is always a neutral number. Yes, indeed, they are perpendicular. So x equals 4, it's perpendicular to y equals 2. Again, the upside down t, that means it's what? Perpendicular. Okay, so now let's see what else that we have. Find the distance from a point 1, 0 to the line. So 1, 0, that's a given point here. In order to find out the distance, it's always guaranteed that's the shortest distance, as what we mentioned about that for the previous sections. So this one is the shortest distance. So one thing that we notice, so this one, it's just the point, which is considered x, y, because we don't know what that is. So once we've been able to find out the value of x, y, so we can get the distance of this line segment. It's perpendicular. So what we can do, we can start it off with the slope of this given line right here. So y equals negative x plus 3, so the slope would be negative 1. As we can see that the distance from the external point to the given line, the distance here, the line segment, it's always perpendicular. If that's perpendicular, so that means the slope is always negative reciprocal. So then that turns out to be positive 1. And then using that the slope and the given point, so we can generate the slope formula, which is y2 minus y1, so y minus 0. So that equals x minus 1. Okay, so using the slope formula, and set that equal to the slope, 1. So 1 is always written as 1 over 1, or negative 1 over negative 1. Doesn't matter which way that you put it. The negative got cancelled. So y minus 0 equals 1. So that means y equals 1. And then x minus 1 equals 1. So that means x, what is that equal to? 0. So what we found here, so the position for that point, then that will be considered 0, 1. Oops, 0, 1. But again, if you just check the work here, does that make sense? 0, 1. Okay, so not quite, right? So we want to get the distance. Okay, so we do know that the relationship is perpendicular. So we get the slope of the given line, negative 1, and then m2, which is 1. Okay, so if you just count it, this point here, it looks like it's what? It's 2, 0. So I think I did the math wrong here. Okay, let's go back. Okay, so it's 2, right, I did the math wrong here. So this one is the right way to do it. But see this part right here? So the y value, that's correct. But what I did here, add 1 on both sides. So this one's supposed to be 2. So it's 2, 1. Okay? So again, find the slope, convert that to the negative reciprocal because that's perpendicular. So set up the slope formula from the given point to the unknown point. Okay, so get the y value, get the x value. So once we get the xy coordinate, and guess what? We can get the distance. So the distance for this point here, for this 2 point, using the distance formula. So the distance formula, as what we talked about before, x2 minus x1 quantity square plus y2 minus y1 quantity square. So x2 minus x1, so 2 minus 1 quantity square. And then y2 minus y1, so 1 minus 0 quantity square. So what we found here, 2 minus 1 quantity square, that's 1. 1 minus 0 quantity square, that's 1. So the things that it's square root of 2. Another way you can figure it out is just by counting the unit rise over run and using that the special right triangle, which is something that we'll talk about later. Okay, but so far, just apply that the slope formula and the distance formula. So here's another example, so you can always find out what that is using the exact same kind of technique. Okay, so number 7, also quite similar. But now let's do one more. So number 7, so this one, the slope is negative 2. And we do know that the slope for this one would be negative reciprocal. So then that would be considered 1/2. And then using that the slope formula, again, the unknown point on the line right here is x, y. So y minus 6 divided by x minus negative 1. So this one, you want to set that as 1/2. So y minus 6 equals 1, so set it out separately. So x plus 1 equals 2, so y equals 7, and then x, this one, that will be 1. So we got a point 1, 7. So once we get the point, so you want to find the distance in between those 2 points. So using the distance formula, so 7, well, 1 minus negative 1 quantity square, x2 minus x1 quantity square, that's what we found. And then y2 minus y1 quantity square, so 7 minus 6 quantity square. So 1 plus 1 quantity square, then that'll be 4. 7 minus 6, 1 quantity square, then that's 1. So the distance would be root 5. You know, for the textbook there's like a distance formula from an external point to a line, but there's no need to apply that special formula. So we just want to do it separately. So find a given point first, and then using the distance formula to get that the exact same length. So the exit ticket, it's just like what we've been doing. So write an equation of the line that's parallel and perpendicular to the given line passed through the point 3, negative 1. So like the previous example that we just went through. So going back to the topic question here. Okay, Okay, so going back to the previous pages, all the way back. Essential questions. So how can you write an equation of a line that's parallel or perpendicular? So step 1, guess what you have to do? Find the slope of the given line first. So once you get the slope of the given line, and guess what? If that's parallel, so that means we're using the exact same slope. If the lines must be perpendicular, so that means we're using the negative reciprocal slope. So negative reciprocal. So once we get those new slope there, guess what we can do next? Using the given point, okay, which is what? x1, y1, and the slope that we found from step 1, and then using the point slope formula to write the equation of a line. Okay, so just like a two-step problems. Okay, so again, any questions that you have, you're more than welcome to put in the questions, comments on my video. And if you guys do like this video, so please subscribe to the YouTube channel. Okay, so I'll see you guys next time. Have a great one.